Okay, the question asks, two blocks stacked one on top of the other slide on a frictionless horizontal surface. The surface between the two blocks is rough. However, with a coefficient of static friction equal to 0.50. The top block has a mass of 2.8 kilograms, and the bottom block's mass is 4.3 kilograms. If a horizontal force F is applied to the bottom block, what is the maximum value F can have before the top block begins to slip? Okay, so let's start off with a free body diagram. Just to explain, this is the top block and this is the bottom block, and forces being applied to the right. So let's look at the forces for the top block. So there would always be normal force pointing up and also gravitational force pointing down. And then there's frictional force pointing to the left. So since the block is trying to slide to the left, acceleration would be pointed to the left also. Now let's go to the bottom block. With the other block, it has normal force and also gravitational force. But then there's also the applied force going to the right, which means that acceleration would also be going to the right. Now let's go to our given. So for our given, for the top mass, it would be 2.8 kilograms. For the bottom mass, it would be 4.3 kilograms. And then the coefficient of static friction is 0.50. Okay, now let's go on to what equation we will use. So we will use F max is equal to the coefficient times the mass of the top block plus the mass of the bottom block, and then that times G. So what the coefficient is 0.50, and then that times both masses, which would be 2.8 plus 4.3, which would equal 7.1, and then also G, which is 9.81. And then, if you multiply all these numbers together, we will find that F max is equal to 34.8 newtons. And in order to try and check this, we will do 34.8, which is the F max, is equal to the coefficient, which we'll try to solve here, that times M1 plus M2, which we already know that it's 7.1, and then also G, which would be 9.81. So if we just divide this, both the masses and G over, we will find that the coefficient would be equal to 0.50. So we have found what the answer was, which was F max is equal to 34.8 newtons, and we have just checked it, and it seems pretty right.